This is another part of our lesson on 6.6 Pythagorean theorem. We're going to look at the quickest way to solve a right triangle if you know two of the sides. It can't be applied all the time, but when it can, it saves you a ton of time. It's the concept of Pythagorean triples. So Pythagorean triples are non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So here are some examples of common Pythagorean triples. And we're going to show you why this makes your life a little bit easier. 3, 4, 5 is a triple because 3 squared plus 4 squared equals 5 squared. Think about that for a second. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. That's why 3, 4, 5 is a triple. Now, how does that help you? Well, let's say you have a right triangle. And let's say your legs are 3 and 4. How long is the hypotenuse? Well, we just talked about it. 3 squared plus 4 squared is 5 squared, so your hypotenuse is 5. There's no calculation. So the next time you see a situation like this where your legs are 3 and 4, your hypotenuse is 5. Here's another place you can use it. Let's say your hypotenuse is 5 and one of your legs is 3. How long is the other leg? It's 4. Now, these other triples work the same way. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. So when you see an example like this, where you know the legs are 5 and 12, 5 and 12 would be the legs, those are the two shorter length segments. The 13 is the hypotenuse. So the number that's in this slot is always your hypotenuse. There's no calculation involved. 5, 12, well, that's 13. So if you take some time and get familiar with your triples, it's going to save you a ton of time in the future. Let's throw another one in here. Let's say you have a right triangle where the hypotenuse is 25 and one of the legs is 24. How long's the other leg? 7. 7, 24, 25. Okay? So these are common Pythagorean triples. Now, I'm going to throw another one in here just to point something out. Let's say one leg is 6 and one leg is 8. How long is the hypotenuse going to be? Well, I know that it's going to be 10. And I don't see a 6, 8, 10 Pythagorean triple here. However, if I take this common triple, 3, 4, 5, and I multiply them all by 2, notice what you get, 6, 8, 10. So if 3, 4, 5 is a triple, 6, 8, 10 is a triple as well. So if you know one triple, you can actually generate infinitely many triples if you wanted to. So if this is a triple, all the multiples of these numbers would be triples as well. So all the multiples of 2 would be 6, 8, and 10. That's how you know if a leg is 6 and 8 that the hypotenuse is 10. Okay? And that works for every single triple, and it works for every single number. I multiply these by 2. You could multiply by 3, or 4, or 5. Multiply them all by that same thing, and you get another triple. Okay? So if we were to write out every single one of these multiples of a triple, you'd have infinitely many. That's why we don't do it. Okay? So you just kind of have to be aware that maybe these numbers go into these lengths. And keep your eyes open for that. Okay? Now, there's a couple pitfalls with your triples as well. Let's go back to our 3, 4, 5. We know a 3, 4, 5 triple. What if I give you this example? See how two of the sides of a right triangle are 3 and 4? Does that mean that this is 5? Think about that for a second. The hypotenuse should be the biggest side. How can that be 5? It can't be. That is wrong. You need to really watch yourself there. If you're using a 3 and a 4 in a triple, those need to be the legs. That third number needs to be the hypotenuse. The hypotenuse has to be the biggest side. Okay? Now, here are most of the common triples that you're going to encounter, and these are all different. They are not multiples of each other. This is attached in channel 6.6 as a PDF file, so you should probably print this out and have this in front of you when you're working with your Pythagorean theorem, because if you notice two of these numbers in a right triangle, then you can apply your triples. Okay, so they don't always work because sometimes you have decimals, or sometimes you have one of those situations where one of your legs is 3 and your hypotenuse is 4, right? It's got to work where it's leg, hypotenuse. Okay, so it can't always be applied, but when it can, it's really going to save you a lot of time.